Excellent. Okay, well, let me send out the roll. Well, welcome to class. We are in April 13th, so I believe we have about 5 weeks of lecture still, about 5 weeks left, 10 lectures or so. And so I really need to take and want to make the most advantage of our time to make sure everyone has what they need to know to build out their full stack applications. So for today's lecture, I want to kind of just go over the general concepts of an HTTP server, because I was talking with some of the students, and after covering them in detail, all these concepts in detail as they relate to Express and as they relate to the HTTP module from Node, I think there's still kind of a hazy notional idea of what it is a web server, what it is an HTTP server's responsibilities are. And so I want to better articulate in a more general kind of concept what it is an HTTP server is, so you really understand what the Express server is providing to you, and you really kind of get a strong notion of what you built from scratch in Lab 8, which was a web server, HTTP server, using just the HTTP module and having to define your own Mime types and whatnot, where you can rely on a framework that already had that technology, that functionality built into it. And then after we do that, I don't imagine this should take longer than 20 minutes or so, since we've already seen a lot of these concepts in practice across 2 labs now. I then want to pivot and actually do a lecture relating to user authentication, user authorization across a web application, so that I can assign the next lab, which will be a user authorization lab that will allow you to essentially build a login application where you can create a name, a username, and a password, and be able to recall those sessions again and again on your server. And so that's the tentative plan for today's lecture. So let me hop on over to my slides here. So here we will talk just briefly about HTTP servers. The overview of this will just be a quick introduction. What are the server's responsibilities? What's the difference between a static versus a dynamic server? Really, what are these request response objects that we keep passing around on the server? What are routes and response handlers? We'll look again at these status codes. We looked at them before when we were doing REST client stuff, so we'll go ahead and look at them from the server perspective again, since now we're issuing those status codes as a response. We'll look at what is a MIME type. Now, I don't want to go too much into detail with that because that's handled for us through frameworks, but it's important to at least know what they are as a full stack developer. I do want to talk about HTTP headers because they give a lot of context to both the client and the server as to what is going on with either the request or the response. It gives a lot of meta information that's important to know, or other data that's relevant for the server that may be separate from the request and the response itself. And then I'm going to briefly mention sessions and authentication since it is something related to HTTP. But I have an entire lecture dedicated to this, so I don't want to spend too much time in this set of slides talking about it. And then I'll just briefly mention cores again, although I've mentioned cores in the Express lecture. So again, I don't want to spend too much time rehashing something that's we already talked about. Let's see here. There we go. Oh no, I'm not sharing my screen. Thank you. Okay, so let me go to share screen, share. Okay, can everyone see my screen now? Excellent. Well, at least I didn't get too deep into the lecture before realizing that my screen wasn't shared. So all I did was show this the overview page for this first part of the lecture. right here. All right, so we'll just jump right into this. So what is a web server versus what is an HTTP server? That's the first thing I kind of want to get over, because there is a difference. So an HTTP server is that application that listens for a client HTTP request and it sends a response back. And so a web server contains an HTTP server, but a web server can contain more than just an HTTP server. It can contain the files that it has to serve to a client. It can contain additional frameworks or applications or logics or connections to things like databases to be able to better manage what the client responses are. And typically a web server is also, well, connected to some kind of network that allows it to be connected to the internet. Where an HTTP server doesn't necessarily have to be connected to the internet. We've used HTTP servers a lot just to test our code locally without necessarily having that server connected to the internet. So if I were to draw a diagram of a web server, it would contain within it an application that's serving as an HTTP server. And then the web server itself would go ahead and listen for those requests from the HTTP server, but it would also then contain the files that it can go ahead and send back. Okay, so what are some responsibilities for an HTTP server? Well, it listens for HTTP request. Maybe I'll do this. Not just HTTP though. This is going to be, what is the responsibilities for a web server? Well, it's going to listen for HTTP requests. It's going to provide a response, but not just provide a response. It has to ensure that it also closes that connection. In one of the labs, I purposely had it set up where we did not close the connection so that you could see what happens at the browser end when we send a request out to a web server. It will appear as if your browser is constantly loading indefinitely, waiting on the server to send back a response. So if the web server fails to send a response, it's going to create a infinite cycle on your client, which is waiting for that connection to close. So obviously that's the responsibility of our web server. Another big responsibility that we'll rely on our web server to do is maintain any private data. Private data might be like user accounts or like hash passwords or like API keys that you need to access other services that you want to render to a client. So all these things, anything that's designed to be private should never, ever, ever be defined inside your front-end code, because your front-end code is easily browsable. It's viewable from the console. So if it's designed to be something that is hidden, then we hide it on the server side. That's one of the responsibilities of our web server. Another thing is we rely on the web server to define for us what is the source of truth. So if we have data that's shared across clients, clearly that data is served or given to us by the server, but it's always the server's state of the data that we consider to be the true source, the true state of that data. So if the data falls out of sync, and to give an example of this, imagine if we built a multiplayer game that had 3 characters on screen, and if one character hits the other and kills them, then we depend on our server to say that that character is dead. Because otherwise, it might be the case that in one client the character is dead and it's not in the other. And so for that reason, we have to decide, well, whose state is the true state of that character. And so we rely on the server to essentially define what the true state of data is at any given time. And this is a pretty critical thing, simply because we're talking about a networked application. We're talking about an application that runs across usually very different machines. And so there is latency. There is the ability where you might lose connection, or as you might recall, HTTP is a protocol where you don't have a two-way constant real-time flow of information. So constantly having to pull or query the server for data is something that's pretty valuable. Again, another example of this might be a chat room, or like a forum, or like some message board, where you might have new messages and you have to hit refresh to see what new data has been added in. Okay. Some games use a JSON file instead of a server for tracking if a player has been killed. Yeah, so there's a number of different ways that you can go ahead and transmit that information from the client. So you can have essentially the server track everything and actually either do server-side rendering on the game or transmit the state of the game via like a JSON file to the client, and then just have the client render the game state on its end. Or there might even be other approaches. I mean, one of the nice things about developing software is that you can create whatever scheme allows you to synchronize data across multiple machines. But I'll try to show you the ones that are most common from the applications that I've seen. Okay, so a quick descriptor as opposed to what is a static server versus a dynamic server. And to highlight what a static server is in terms of an example, GitHub pages, what we've been using to deploy all of our front-end applications or portfolio pages, has served as a static web server. And so a static web server consists of an HTTP server, right? So it does handle requests, but it's static because the server sends its hosted files back to your browser, and that's it. That's all it does. It only responds to GET requests, and it only responds to GET requests to serve back files that it's hosted within it. There is no server-side logic. There is no server-side code inside of a static web server. Its one job is it receives a GET request for a file, and it delivers that file. A dynamic web server is a little bit more complex than that. It consists of a static web server, right, but plus extra software. It's mostly common an application server, so namely it will have some kind of application layer and a database connected to it. That's when we start creating true full stack web applications, we're talking about building dynamic web servers where there is logic, there is code that resides on the server side that makes decisions. There is data that's maintained in addition to files that's maintained on the server side. The server side has to make decisions such as authentication, or it has to broadcast information to various clients, or it might have restricted routes that a logged in user might have to be able to log in to access. So when we're talking about building our full stack application, we're talking more about starting to develop dynamic web servers. And dynamic web servers are not something we can publish onto GitHub pages like we were with our static web pages. And it is because it requires a runtime environment. It requires a node runtime environment where we can define what request we can accept on web servers. It's not just GET requests. We can get POST requests, PUT requests. We can accept delete requests. And we can define routes and handlers on what we do whenever we get any one of those requests. So we can customize a lot of behavior inside of our server to respond to a lot of different actions. And then our server can then be a client to other backend services. And sometimes those are like a database, right? A lot of times you send data to a database from your backend server using a REST API in and of itself to go ahead and store your data. Okay, so just a quick mention on these request response objects. We've seen these in Express. We've seen these inside of Node while building our lab. So the request obviously maintains the meta information about an incoming HTTP request from some client. But in addition to that, it contains a body, right, or string query that contains data from the client. So it gives me my meta information. What is this request about? And then what is the contents of this request? What is the data that this client is trying to share with the server for whatever action it wants it to perform? But on top of that, the request can also include additional objects that are important for the server to do its job. These objects might be such a session object, so that we might be able to identify a client. Recall that HTTP itself is a stateless protocol, and so these request objects from an HTTP request, we can extract from it information, and then when it's in our runtime environment, we can then take that header information and construct an object, a JavaScript object from that. But that can help us identify when a client is revisiting the server, so that we can serve them their profile page, or we can serve them their character information, or we can serve them their shopping cart information, so that we can maintain a sense of state with a client, with the same client as they make multiple requests. Then these response objects, a response object maintains the information that's going to be sent back to the client, and a response object also has methods for sending data back to the client, but also for ending the connection. And so we got to see this in one of the labs when we implemented a getter, but we never sent back a response, and we never sent back a response that then terminated the connection. And so on the browser side, on the console side, we got a message from the stating that we received a request, but on your browser side, it was just infinitely loading, and that's because we failed to send the response. We failed in one of our responsibilities as an HTTP server in that regard. Okay, so let's see here. Let's talk about the HTTP route and response handler. So when we've been designing all of our lab stuff in Lab 9 with the Express Labs, and even in Lab 8 with the HTTP server, we typically do two things. We listen to a route, and then we respond when a request comes on that route. So let's talk about what is a route and what is a response handler. So a route refers to how an application's endpoint responds to a client request. So an HTTP server listens to two things: a specified URL path, and it listens for a specified HTTP method. So those two things have to be aligned for our server to respond. So the URL path we've seen before might have been like the root directory, just like /, or it could be like /submit, or it could be /about, right? That illustrates where in the address bar, when we go ahead and enter the domain and then the domain path, where we're going to listen on our server for a particular request. And then there's multitudes of requests we can get on any URL path. We can actually listen to the same URL path for different requests, for a GET request or a POST request, and then we can assign different response handlers to do different actions when we get a request on that path. So these two things define a route. And then we bind to a particular route some function in our server that handles that request and sends back a response to the client. And so again, we've seen this lots of times now in Express, and that's just what we mean when we say response handler. But the response handler is the very last function that should return back, that should terminate the connection between the server and the client. So any actions that have to happen before you disconnect, before you end that connection, you should do before your response handler. And so that's where our middleware functions should occur. So in Express, there are lots of actions we might want to do, such as parsing information and using it to do some kind of process before delivering a response back to the client. And so we would do all those actions before we trigger the response handler. Status codes. We've seen a lot of status codes. I believe we hard-coded a lot of these status codes in Lab 8. These are just HTTP servers include a status code in their responses to indicate back to the web client whether their request was successful or what the status of their request was. And so I'll reiterate that there are typically 5 common responses, or there are 5 groupings of responses. If it's a 100 numbered response, it means it's some kind of informational response. If it was a 200 response, something in the 200 category, it means it was successful. If it was in the 300s, it means that you got redirected in some kind of way. If it was a 400 response, then some kind of client error. So a 4404, for instance, is trying to request from a page that doesn't exist. So that's an issue from the client itself. Anything that's a 500 response is not a client error, but something that went wrong in the server. So typically, that's just a generic error that occurs, just to let you know that something happened on the server side. So the most common codes that you've probably seen are 200. This means is okay, everything went as per expected. 301 just means that you got causes a redirection. This is a permanent move. A 302 is a temporary move. Probably see 302s more than 301s, but either redirect should produce that status code. 403 is forbidden, so this is going to be an authorization error. It means you're trying to access something that you don't have the authority for. 404 is there is no file found, or there's no resource found at that particular path. 500 is the collection status code for any unexpected server error. So it doesn't really give you too much information, except for the fact that the problem's on the server end. And then 503 is service unavailable. This is different than a 500 where there's some kind of issue or error that happened to the server. This means that there's an availability problem on the server. So if, for instance, the server might be overloaded at this time, and you might have to wait a while to send another request when it has availability to be able to respond to it. So in Lab 8, you saw probably for the first time Mime Types. So let's talk really briefly about what Mime Types are. It stands for multi-purpose internet mail extensions. But really what it is a media type. It's a standard that indicates the nature and format of a document or a file or some assortment of bytes. So it's important to understand that browsers use that MIME type to identify how to parse and read a file. It does not use the file extension. So whereas your OS might use a file extension, like your OS might look at .txt or .html or .js or .java and make a decision, oh, what application am I supposed to use to open up that file type? The browser uses the MIME type for that reason. So it's worth knowing that the MIME type is defined inside that content type header. So again, our request responses, our HTTP request responses, they have headers that have relevant information. One of the important relevant informations is content type, where it gives the MIME type to let the browser or the server know, predominantly the browser though, because we have control on the server. We can break this convention, but browsers can't. Browsers have to use the MIME type to be able to identify how it's going to open up a file. So it's just worth knowing that that's how browsers determine what a file is, whether it's a text file, or whether it's a music file, whether it's a video file. And of course, the common MIME types I just list here. I don't want to go too much into detail. You just have the application types and the audio types. You have image types, multi-part types, which might be like zip files, text types, and video types. Anyway, and so pretty much the other big part that's really worth knowing with HTTP servers and managing HTTP requests is the vast amount of HTTP headers that exist. And of course, all these headers exist to provide information regarding either the request or the response. Headers can exist on either a response or a request. And so just to give a quick overview over what the headers might contain, it can have things that relate to authentication. It can have information that relates to caching inside of the browser or inside the server. Typically inside the browser, though, because again, we get to control all the behaviors inside of the server. A connection management. And let's see here, the content negotiation, like what we can accept or what we can accept in terms of encoding or what kind of languages to accept. Cookies, which we're going to be talking about in just a moment. So it's important to understand, though, that all cookie information is embedded into an HTTP header. The message body itself, so information related to the message body, like what is the content length of the message body, what is the type. Again, we just talked about the MIME type there. How is it encoded? What is the language? Where's the location? Any kind of redirect information, like the location of such redirects. The context of the request, such as from, or the host, or the referrer, or the user agent, the application that's making it. Or we can also embed information or context about the response, information about the server, or what's allowed. So that's a quick overview of HTTP headers. Really, you'll get more and more comfortable as you build out more applications, honestly. And as you build out more applications, you'll have to start accessing more and more information from an HTTP header. And that's realistically where you'll really learn more about it. But as you're working on your full stack app, I included these slides so that you could get you could, in your own time, kind of look over them and get a strong impression of what you might have to extract from there. And in the labs, especially this next lab, you should get a strong understanding of how we're going to be able to store session information and extract session information to the server to go ahead and serve a particular client repeatedly, to identify a client. Anyway, I don't want to spend too much time on sessions. I have slides in here, but I'm about to do a lecture all on this, so we'll skip past these for now. And I've already talked a little bit about the cross-origin resource sharing, but the HTTP headers or web server allows us to relax the origin constraint, and that origin constraint is trying to prevent any kind of snooping or privacy invasions. But if you control the front end, and if you control the back end, then it's okay for you to relax these constraints for your application to do what it needs to do. But I added these because it is a role that the web server plays. And I believe this got covered inside of our lecture on Express. Anyway, so that's just a quick overview of an HTTP server and its responsibilities.